Hey guys, today we're going to be going over Module 5, Chapter 7, which is Decimals, Real Numbers, and Proportional Reasoning. And I am Katie Hardister. Let's jump on in. So we're going to start by converting the decimal into a fraction. So the way that we would do this is start by just moving that decimal. So we could move it 1, 2, 3 places and then place our decimal there. And we would know that in a math equation, this would look like 225 over 1,000. And we got 1,000 because we moved this 1, 2, 3 places. So the decimal, 3 places. So that's how we know, that we need to put 1,000 because it has 3 zeros. So we would divide that by 25 over 25, and that would give us 9 over 40. So from here, what we would do is we would just find what is called the prime factorization. So to do that, I'm not going to do both. If we were in an actual classroom, then I would do both the numerator and the denominator, but let's just take a look at the denominators. So we're going to take a look at this fraction here, and then the answer to the equation here, which is 9 over 40. So taking a look at, let's do 40 first, a smaller number. So 40 can be broken down into 2 and 20. 20 is not a prime number, so we're going to keep breaking that down. 2 and 10. 10 is not a prime number, so we're going to break that down again into 2 and 5 because we want to break these down to the smallest prime numbers that we can. So then taking a look, and that would be the solution, of course, to that prime factorization of 40. So then we're going to take a look at 1,000. And this one's going to be bigger because it's obviously a bigger number. So we could break that down into 2 and 500. And we could break 500 down into 2 and 250. And then 250, we could break that down into 2 and 125. And then we could break that down into 25 and 5. And then we could break that 25, of course, down to 5 and 5. Something that is useful to students is to actually go back through and to circle each prime number on your factorization. These are actually called factor trees, and they are pretty fun and useful to students. So we could just circle each of those numbers. So like I said before, we would do that for, of course, the numerator and the denominator, but for the purpose of this presentation, we're not going to do that. So moving along to another one. Again, reiterating that rule that I said, when converting a decimal into a fraction, we're just going to move the decimal however many places. So in this case, again, by coincidence, 3. So we remember that 36 would need to go over 1,000 because we moved it 1, 2, 3 times. And then we're going to multiply that by 4 over 4. And that would give us the solution of 9 over 250. So moving along to our graphs here. So we have the equation y equals x over 2. So what we would do here is I've kind of made this little graph for us, and this is of course our y, and down here would be our x. So these are our axes, x and y. So these are coordinates, and I went ahead and made the graphs so that we could practice our plotting points. But what we could do is kind of think of a scenario for this. So our scenario would be that, say I have shoes. So I want to know how many pairs of shoes do I have. So if I go to my closet and I count, well, first I have none, so 0 and 0. So I can put that right here in the very middle of our graph. And then I could count, well, I have 2 shoes. 2 shoes is 1 pair of shoes. See how that makes sense? And then 4 shoes would be 2 pairs of shoes. And so on and so forth. So 6 would be 3 pairs of shoes. And 8 shoes would be 4 pairs of shoes. And see how that's a diagonal line going this way because it's positive. So then my fiance comes home and he says, you just have too many shoes and you need to get rid of some. And I think he's crazy, obviously. But, so again, if 0 is here, so let's say that I subtract, here's our new formula, so y equals negative x over 2. So if I get rid of 2 shoes, so number of shoes given away is 2. 2 given away gets me down to 1 pair of shoes, or I'm sorry, 1 pair of shoes given away. And so I would do the exact same thing I did earlier. So if I give away 4 shoes, then that's 2 pairs of shoes given away. So if he asked me, well, how many shoes, have you given away? Then I could trick him and I could say, well, I've given away 8 shoes. And maybe I could trick him and he wouldn't realize that I've actually only given away 4 pairs of shoes. But we can see that this way, forgive my line, this way, and it will go on and on and on, hopefully not too far, it would go on, and that shows that it's, of course, negative. We're getting rid of something. It's negative. So then, one night, when he's gone, I go to the store, and of course, I've given away all my shoes. Probably just have 1 pair because can't go outside barefoot. But, so we start with 0 shoes, and that's what he thinks is that we have 0. Then, I sneak in 10 pairs of shoes. So I would go, in one day, I snuck in 10 pairs of shoes. And then, we could go on and on and on. And then here we take a look at if I have my number of shoes, of course, again, this is the pairs of shoes. So I had negative 4 over 4. Let's see, 4. If I gave away 4 shoes, then that would be, 4 pairs there. And so we could see here that it's a line, that it's a hump. We hit 0 and then we gained more. So taking a look here, these are kind of fun because what we can do, let's start with this one. Here is a square and it is divided into 4 sections. So 1, 2, 3, 4. But what we're trying to figure out is how much of the square is actually shaded red. So looking at it, it's kind of confusing, but what we can do is we can actually cut these right down the middle the best we can. We know that we're trying to cut them down the middle. And then we can count. So we can say 1, 2, 3, 4, 5, 6, 7, 8 sections. So I could say that 1 out of the 8 sections is shaded red. And I know that if I was to, do the opposite of what we did earlier, converting the fraction from a decimal to a fraction, then I could actually convert this fraction to a decimal or a percent. So I know that 1/8 would be 12.5%. So I could say 12.5% of this shape is shaded red. So what about this one? Let me change colors because that's going to help us kind of decipher here. So if I was to draw a perfect, y'all know Miss Katie here is just perfect with her drawings. If I was to shade this, or cut it straight in half, and I see this little section here, doesn't that little section look the exact same as this section? So if I just took that and I put it right there, wouldn't it look like this circle was shaded half red? I think so. So 1/2, because there's 2 sections. So 1/2 equals, and it's kind of obvious, but we could, of course, put it in the calculator or do the math to convert this fraction into a decimal, which would give us 50%. So what about this one here? So if I shaded, cut each of these, then I could do the math, or I could just leave them how they are, and I know that there are 1, 2, 3 by 1, 2, 3. So 3 times 3 equals 9. There are 9 boxes. So I can say that 9 is going to be my denominator, which is the number on the bottom. So again, we're looking at how many are shaded red. So let's just number them. 1, 2, 3 and a half. So I could say excuse me, 0.5. So 3.5. And that would equal, if we did the math, of course, 38.8%. Excuse me, I'm going to have to get a quick drink. I have something in my throat. Okay, so moving right along. We could take a look here and we see that a yellow hexagon is 100%. So if we take a look, then maybe we could even say that a red trapezoid would be 50%. Oh, let me back those up here. So if this is 100%, and the red trapezoid would be 50%. Then we could do process of elimination, and we could find out, each percent of these, what would they cover. So looking at our gingerbread men. So I made gingerbread men and Christmas tree holiday cookies, and I want to know what percent of all the cookies I made were gingerbread men. So what I can do is I can number them. So 1, 2, 3, 4, 5, 6, 7, and 8. So I could say 8 is going to be my denominator, which is the number on the bottom. So then I could count that I have 1, 2, 3, 4. 4 over 8. So 4 over 8 simplifies to 1 over 2, which is 1/2. And we know from our previous question that 1/2 equals 50%. So I would say that 50% of my cookies, of all the cookies I made, were gingerbread men. All right, so then I want to know, 4 of the cookies have ribbons as decoration. What percent of my cookies were decorated with ribbon? So I could, just take a look at them again. We obviously know that there's 8 cookies here. So 8. And it tells me here that there's 4. 4 of them are decorated. So again, we would just do the same math. 4/8 converts to, or simplifies to 1/2, which equals 50%. So 50% of my cookies were decorated with ribbon. Or 100% of my gingerbread men were decorated with ribbon, whichever way you want to look at that. So looking at this equation here, so I want to give my cookies to my friends as a holiday gift. Only, that was supposed to be 40. Let's see. Only 40% of the cookies will fit in the box. How many cookies are in the box? So what this is asking, it's kind of confusing to just look at the equation or look at the word problem, but we can convert that into an equation. So I could say 40% of, you can think of, whenever I see of, I automatically think of a multiplication sign. So 40% of blank. So x, 40% of x equals 8, because we know that we have 8 cookies total. So if we were to do the math, then we would see that x equals 3.2 cookies. So am I going to break, my cookies, to have 0.2 of each of them? No. So in this case, I would round down. So I would give each of my friends 3 cookies in this case to fit in that box. I might want to get a bigger box, huh? So taking a look at our last equation here, I was invited to 3 more holiday parties because my cookies are delicious. And I want to take my cookies as a dessert. So it takes me 5 minutes to prepare the dough. So let's underline that. 10 minutes to bake the cookies, and 5 more minutes for the cookies to cool. How long will it take for me to make 3 batches of cookies, including cooling time? So what we're going to take a look at is if I do 5 minutes plus 10 minutes plus 5 more minutes to cool. So I'm going to say 5 plus 10 plus 5 equals 20 minutes, right? So it's going to take me 20 minutes to cook just one batch. Then I can cook another, I would just multiply that by 2 and then multiply it by 3. But let's kind of throw a loop here. What if I'm going to use my oven, and I know that my oven, most ovens, have 2 racks. So if I'm going to cook these 2 batches at the same time, then it would only take me 20 minutes to cook, 2 batches if I'm going to use both of my racks. And then it would take me another 20 minutes. So 20 plus another 20, it would take me 40 minutes total to cook 3 batches of cookies total. Anyway, I think that's all I have today, so I hope everyone has a great holiday, and hopefully y'all get to eat some cookies as well. Thank you.